My name is Josh Bradley. I'm here from Fastly. I'm a senior manager on the foundation engineering team. And I'm here to talk about scaling Graphite with ClickHouse. So this is a little bit more of an internal platform that we run. Foundation engineering at Fastly is essentially an internal platform for the rest of our engineering teams to use. And this is one of the challenges we had, and this is how we solved it. So hopefully this will be interesting for you. Quick intro, what is Graphite, how do we use it, going through that. But I do want to say, I am a user of ClickHouse internally. I'm coming here speaking on my own behalf, so this is not necessarily an endorsement from the company, but we do use it in a number of ways internally. But for those of you who aren't familiar, who are we? Who is Fastly? In case you haven't heard, we're making the internet a better place, where all experiences are fast, safe, and engaging. That's our goal. We're an edge compute platform. We run in hundreds of physical locations across the world. Go check us out on our Fastly network map. You can see all the locations that we're connected at. We have a tachyometer on there, how many requests per second we're serving at that given moment. Usually it's somewhere in the low dozens of millions of requests per second. And so this is partially the challenge that we have. We are dealing with millions and millions of requests per second. We have to collect this data, and we need to put it somewhere. So what is Graphite? Quick show of hands from the audience, just out of curiosity. Has anyone heard of Graphite? Has anyone used Graphite? See a couple hands, 2, 3, 4. All right, yeah, all right. So Graphite is a open source telemetry system. It's been around for a good long while. It was originally written in Python, and it's composed of a couple of components. Graphite Web's your front ends, REST-based. It's originally written in Django. Carbon is the internal daemon that is going to collect your telemetry and respond to your various queries. Whisper is a custom data format that is like a round-robin database, and that's how you store your data on disk. So essentially, this is giving you sort of an example of a very simplistic high-level Graphite deployment. Challenge that anyone has run Graphite at scale runs into very quickly is that the underlying file system-based time series storage doesn't scale particularly well, right? Whisper, being a round-robin database, is incredibly write-intensive. By default, it is sort of pre-calculating and pre-allocating the storage that it needs in order to hold all the time series in it. So it's like a byte offset, down to like 12 bytes per data point. So every unique metric that you have is going to create a new time series. So the question is though, like, okay, well, if it's been around for a while, we're a modern company, why are we still using Graphite? Well, there's some historical rationales for this, right? So one of the things that really got Graphite off the ground, and I think a lot of people continue to use it for, is the ease of collection. Graphite just receives data. You just send it to an endpoint. You can put some bits on a wire and you have a metric now. You can send it over UDP, TCP if you want to get crazy and reliable. But the metrics are expressed as a simple text-based dot delimited hierarchy. So you could have, production, region, server, application requests of value and a timestamp. That's your metric. You can just crank those out arbitrarily, and people do. The number of query functions that are built in with the service actually make it really engaging for data analysis. Lots of histograms and quantiles, throw some Holt winters on there, get some magic. And the fact that it's really good at accommodating sparse data sets, delayed data sets, backfilling, rewriting data, whereas some of the more modern technologies, I'm not going to name and shame, but don't handle that quite as well, or it becomes a little bit more expensive. So because of what I was just referring to, we're collecting hundreds of discrete metrics from our real-time stats pipeline. So as customers are interacting with the Fastly platform, every click, every request response, every computed edge app, bot detection, WAF rule is generating an event, sometimes several of them. These are going into our real-time stats pipeline. Some of this is being delivered to the customers, but a lot of it we need internally in order for us to understand like what is happening with this platform. How can we help proactively engage with our customers to let them know when they're having a problem, when they need to do something on their side. And the last bullet point is kind of a challenge for us. We did it to ourselves, but we encode what we call a SID, a service identifier, into the metric name, right? So think of that dot delimited path. So it's going to be a customer name, some random hash, a service ID, and the service is something that's entirely generated by the customer. So as they introduce new services, they're introducing new namespace, they're increasing the cardinality dimension. We have customers that, for reasons, have decided Fastly is a fantastic platform to put in our CI pipeline. And they will just start ripping through service identifiers. And suddenly we have thousands of discrete services that we're having to handle at arbitrary dimensions of depth that we have to work through. So that's hard. So when I first joined, Graphite was in a little bit of a rough shape. So the Python-based implementation just wasn't scaling. It was overloading. We were having challenges during large football events that happened in the beginning of the year. And it just wasn't keeping up. So we looked at what is the state of the art in this space. At that time, there was a lot of rewrites that had been done in the Golang project. So Go Carbon was a rewrite of the Carbon daemon into the Go service. Carbon API was a Golang-based Graphite API compatible service. And we had some contributors at Fastly that also helped make that happen. That was fantastic. So we had now, we got away from some of the challenges with the legacy Python implementation. The new daemons were able to keep up with the load, but remember that whisper problem we were talking about? The storage was still the limiting factor. We were scaled as vertically as we could on these Graphite systems that we're running. So we are Fastly, we love speed. SSDs are our bread and butter. We put them in everything. And we had the most SSDs that we could possibly fit into a single server. And we were still like maxing out at about 80 terabytes of capacity per node. And it wasn't a great place to be. And again, thinking about the fact that customers can influence the shape of our data very quickly, like we needed a better solution. We needed some way to handle this. So, okay, we need to scale this into the future, but we kind of had a primary, secondary, but it wasn't really highly available. It was, choose which one was active at that moment. And then when it got sad and unhealthy, change it over to the next one and hope that everything was great. Hardware couldn't go any further than it was. Like we had as much as we could pack in there. These were large drives, the largest available at the time. I think might still be. And the hardware was running in a legacy data center. So again, we have physical data centers everywhere, but we needed to vacate this one. So like we had a really tight timeline. We had a huge volume of data that we needed to physically move and an ever-growing data set that we're consuming. So the goal was fix everything above, right? Like we have to have true high availability. We need to have the ability to scale out horizontally because the data set is not stable and it's coming at us at a very quick rate. And we don't want to have every internal support team change their usage. This should just work, right? They shouldn't even know that we did anything. And so that's what we started to figure out. How do we do this? We cannot break the user experience. We had too many people that were dependent on this particular data model because, again, from a discoverability standpoint, it was very easy to understand sort of the hierarchy of your telemetry based on how we structured it in the system. So if we changed to a new type of backend, we would have to train everyone the new sort of query language, all the dashboards, you'd have this split. It would have been chaos. The components, we really wanted to make sure that this was containerized, planning ahead, thinking for the future. We would love to get this into Kubernetes. We didn't quite get there, but we did get it containerized. And this can't be like just setting money on fire in order to store all this data. We do have to be really cost efficient. Also can't be any slower than the current implementation, which at times could be quite slow. So what did we do? We looked around, we tried to find everything out there. What we ended up settling on is looking at ClickHouse. So there was a growing developer community that had started to leverage some of the capabilities of ClickHouse that made it really good for a time series database system, right? Some of the factors that like really stuck out for me was native support for carbon metrics. It's got Graphite merge tree is one of the default engines within ClickHouse. So it knows how to work with this data, how to roll it up, how to summarize this. The ability for us to move data between partitions with TTLs. So we can say that, again, like not breaking the bank. I want all the most recent data that we're going to be querying for all the time on very hot, fast disks. But after a few days, a couple of weeks, people generally aren't looking at that data. That's the problem with time series. We don't want to get rid of it, but we do want to put it on something slower and cheaper. And so that's exactly what we could do with the ClickHouse schema and say that on this date boundary, take this whole partition, put it someplace else. And we retain the full accuracy of the data without having to expire anything. We also got to the ability within the ClickHouse schema that you can have column level compression. So we are actually able to pack this data in because it's coming in sparse. We can pack it in and compress it on the fly and get really impressive storage capabilities relative to that. Even though you're compressing, you're not burning a ton of CPU cycles. And from the high availability standpoint, we have replicated and sharded this data across multiple availability zones and multiple shards to provide true HA. We can lose any given node at a time, and the data is still fully queryable, fully writable. Distributed tables is a nice abstraction layer that we built on top of this, such that when we have, I'll get to it in a couple slides here, when we write data into this cluster, we don't really have to think about where it's going. Like, it's going to hash our data path, or metric object is going to land on the same node, and it'll automatically get replicated around. And the query performance was just blazing fast. I couldn't believe it. I actually had to go back a couple of times just to make sure that I was querying it properly, because I'm like, this is coming back too fast. This doesn't make sense. But it was actually working. So how we did this, we used a couple of open source components. We stitched this together. Again, we're an incredibly small team internally. So we leveraged Ghost Tunnel. It's open source MTLS proxy. So we do mutual TLS between every node in our cluster. Again, leaning into the Carbon API, which we had previously used, because that provides the interface for the users to request the data from. We didn't want to change that at all on them. But these two new components, Carbon ClickHouse and Graphite ClickHouse, provide the write and read path, respectively, for being able to interface with the backend ClickHouse clusters themselves. Zookeeper was the distributed cluster manager at the time. I know that there's much more capable modern version of that, but we are still leveraging Zookeeper at the moment, and it works pretty well. It's kind of battle tested. So quick shout out to these communities and these components that have been out here. So if you want to explore these, the Go Graphite project up on GitHub provides all these components. You can kind of click around into them. I have another little project I can talk to you later. Ghost Tunnel also fantastic. If you have mutual TLS proxying needs, it's a great tool. So the moment you've been waiting for, my terrible block diagram, but let me walk you through this. So essentially on the right-hand side, we've got data that's coming in, and this is coming in from a variety of sources. Some of this is our stats pipeline. Some of this is our edge collectors from bot detection and telemetry, and they're in various environments. And we're pumping this through into our cloud project. We are running in GCP for this implementation. It's going to internal load balancer. We bounce across a couple of nodes. This is a class that we've called our Carbon controller, right? So it lands on Ghost Tunnel. We validate, okay, did you really come from someone that we trust? Because we've done the mutual TLS handshake. And then we'll write it in through the blue path into, again, another load balancer. Now we're hitting an internal load balancer here because we want to be able to sort of swap out any one of the ClickHouse servers as we go. Any one of the ClickHouse servers can receive or respond to any request, and they will route it around automatically through the distributed table that we've implemented. So again, that's essentially Carbon ClickHouse, Graphite ClickHouse only know about the distributed table. For them, it just seems like the one table that they talk to. Behind the scenes, it's really replicated and sharded. Internally, it's sending data around between the cluster. On the opposite side, internally, we've got our observability front ends. These are internal users that are building out dashboards, visualizations, usually using a tool like Grafana, or they might be querying it through an API because they're building out their own integrations. We've written an internal tool that we have not yet open sourced called Carbon Alerter that allows you to write Prometheus-style alert expressions based off of Graphite querying data and be able to send notifications out. Both of these are constantly hitting this internal load balancer, again, being validated through our Ghost Tunnel schema, and it's kind of hairpinning around between a couple of interfaces because, again, we wanted to keep the API identical for those users, and then ultimately this gets routed into the same cluster. Query, read response flowing right back through there. So that was a very quick sort of run through. I'd love to chat a little bit more if you have any questions. So I could go into a Q&A spot. That's basically what I have.